Okay, so let me show you my screen. Where is my screen? Okay, guys, do you see my screen? My MATLAB screen, do you see that?
Yes.
Yeah.
Okay, perfect. So now, okay, so what can we do? Okay, let's do a little more matrix and then we go to programming, okay, just to do the programs now. I just want to give you a couple of examples. So let's create a matrix, guys, that is let's create a something simple. 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay. Now, there is a new command, guys, that we need to use that is very similar to the ones that we have been seeing. Okay, let me rephrase this one here, okay? Well, just do let's do like that, okay? A is from 1 to 9. Now, sometimes, guys, we're interested about finding positions, okay? So remember, if we do the following, okay? So let's say A1 equals A larger, A larger or equal than 5. Okay, so we have a logical number. So you agree? It's 0 and 1. 1 if we satisfy the condition, 0 if we don't satisfy the condition. Makes sense to you? So this is what we have been doing yesterday. Now, if you want to know the values of this one here, what you can do is simply, for example, A2 can be equal from A, select these numbers here, and then I have the values. Got it? So this is what we have been doing the previous class. Now, what we can do, and there is another command that is really important and interesting here, is the command find. Okay, the command find. So let's do A3. And what we want is find from A larger or equal, we say larger or equal than 5. So you see what happens here when we use the command find. It goes directly to the values, to the positions. It doesn't give you 0, 1, zeros or ones. It gives you the positions where this condition is satisfied. Got it? So if you take a look to A, look. So the positions of A greater or equal than 5 are, of course, position 5, 6, 7, 8, and 9. You agree? So find gives you specific positions. It doesn't give you the zeros and ones. We can do also the logicals with this one here. So let's say A4. Imagine I want to find the values that are larger than 5. But, sorry. What is my... And smaller or equal than 8, for example. Let's see. You see? So you can use exactly the same commands with this technique. Now, can we create the matrix I was creating? So let's do A. Now it's a matrix, okay? Yeah, this one. Can you find me the position where A equals 9? Okay, let's try to find the position when A equals 9 using the find command. if we use the find command, guys, here, A equals 9, what it's going to give me is what? What is the meaning of this 9? It's the position. Okay, so let's try to find when A equals 4. So what MATLAB does, guys, it reads by rows, then shifts by column. So for example, this is number 1, this is position number 2, this is position number 3, etc. And this is position number 9. Got it? So MATLAB goes first rows, then columns. Now, if you're interested about the specific position of a given variable, so what we can do is we can do ij. These are names, okay? And just do do this. Find of A equals 9. So now we have the typical matrix notation. So, find the position, the exact matrix notation of this condition when A equals 9. So what is this 3 and 3?
The row column number?
Yeah, exactly. Row 3, column 3. So let's do another one. Let's do the number that I was telling to you, 4. Row 2, column 1. Is it right or not? Row 2, column 1. Got it? Make sense? Now, there is something that we're going to apply a lot, guys, when we do econometrics, and we do this also in economics. Let's take a look again to A. So there is a lot of times, a lot of opportunities, guys, that we need to vectorialize this matrix. Vectorializing means the following. So the first row, the first column becomes the first 3 rows. The second column goes below. The third column goes below. Okay, so basically what we are doing is we're transforming a matrix into a vector. Okay, so how do we do that? Well, let's call this B. And B is going to be, simply this is the way of vectorizing. Take a look to what happens. You see, 1, 4, 7, first column, 2, 5, 8, second column, 3, 6, 9, third column. Got it? So this is called vectorializing, guys. So you put the data that is in a matrix, you put everything in blocks down. Got it? Now, how do you go back to the original matrix? Do you remember the reshape command? Do you remember that reshape? Reshape simply takes the matrix, vector or matrix, and then reshape is in a shape that you want. So in this case, I want a 3 by 3, right? I want this to be a 3 by 3. Agree? And here we go. So this is the way of vectorializing a matrix, and this is the way of returning the matrix back to the original position. Remember the reshape of, if you want to do more professional this stuff, what you can do is, you know what, instead of this one here, you can say size of B, 1. Well, in this case, it's a square matrix, right? So it's not an issue. Oopsie. No, not of B, of A. A is the 3 by 3. Make sense to you guys? We're going to start putting all these things together very soon. You're going to see. Okay, so let's continue working with A. This is my A. Now, there are a couple of things that, let's create another B, very simple B. Okay, There is another command that we always use. No, for example, I tell you guys, give me the trace of the matrix A. Do you remember how do you compute the trace? What is a trace? The trace equals what? Is the sum of diagonal elements of the matrix. Okay, so we are going to use that later. So how do I compute the trace of a matrix here? Well, there is a MATLAB command also called trace, but let's do this by hand. So let's call this D, okay? And D is going to be equal to, what happens when I use diag? Diag gives me the diagonal of a matrix. You see, take a look to the diagonal elements. You know, when we work with variance, covariance matrices, the variances are in the middle, are the diagonal elements. So this is one way of extracting the diagonal members. You simply put diagonal of the matrix, and it will take the 1, the 5, and the 9. Now, how do I find the trace? Yeah, let's call it trace X, because trace is a command. What I can do, guys, instead of doing in 2 processes, I can do this, right? What do you think? You know that diagonal gives you the diagonal elements, and then I sum these values, and then I obtain what is the trace. Agree with me, guys? This is my trace. Right? I simply take the diagonal elements and sum them all. Now, can you please do we have done this again. Can you move the third column? I want the third column to be the first column, the second column to stay there, and I want the first column to be the third column. Let's call this A left, right. And we know how to do that already. We did something similar already, guys. So you can write your answers in the chat, guys. Guys, this is something that we should know already. So this is matrix manipulation, right? So what I want from A is what? I'm sorry. I want to shift the columns, right? Column 3, column 1, column 2, column 2, column 1 to column 3. So how do I do that? I want all the rows, and what I do with the columns?
I put it in the chat.
Oh, perfect. What about this one here, guys? So I will go from 3, decreasing -1 up to 1. So basically it's going to be 3, 2, 1. Exactly, column 3, column 2, column 1. Make sense to everyone? We can do this a kind of more professionally one. We don't want this to be always 3. So what we can do is we can do this end, or we can do size of a comma 2, right? So any of these 3 works. Now, why do we prefer these ones here that have something specific? Because if your matrix changes size, so you need to be changing your programs. Make sense? If you do this one here, this 3 is correct, but it's going to be subject to A being a 3 by 3, correct, guys? Or A having 3 columns, sorry, not a 3 by 3. Perfect, Nicole, thank you. Good. There is a MATLAB command that is called flip left to right. That's exactly what we have done here. If you take a look. So this MATLAB command is flip left to right. And that's exactly the same as what we have done now. Okay, so now let's go back to A. Now what I want is to shift the rows, the third row to be the first row, the second row to stay there, and the first row to be the third row. So basically, this one goes up, this one stays, and this one goes down. Okay, let's call this A up and down. Yep. I have one answer already. What do you think about this one here, guys? In this case, what I'm changing is the rows, and I want to collect all the columns. Correct? So what I'm doing is I'm going from the size of rows, the number of rows of A, decrease by 1 and arrive to 1. You see that? 7, 8, 9 goes first, 4, 5, 6 stay the same, and 1, 2, 3 go to the last row. There is another MATLAB command, guys, that is, let's call it AUD2, that is flip up and down. Oopsie. Here we go. Everyone is with me now? Okay, so how can you eliminate, for example, I want to get rid of the second column of AUD3. Let's call this AUD3. And the only thing that I want from here is that the second column of AUD, this one here disappears. 8, 5, and 2 disappears. I will create first an auxiliary, just not to delete AUD2. And then what I want is what? I want, sorry, caps. AUD3, right? everything second column to be equal to empty. So this is the way in which you disappear, you eliminate, you delete the column. Be careful here, guys. What I've done is I created a replica of AUD because I want to keep AUD. Okay, normally, if you want to handle data, be careful with deleting, because if you delete, you delete. Right? Better to keep the original data, save it in auxiliary different data, and then you do whatever you want with that. Here you go. You see, so now AUD3 is this column and the last column. It's clear to you? So I think that we can do some programs now. Okay. Questions. So we can start programming, guys. Let's do one very simple example, and then you're going to start working with a couple of other examples. Okay. No questions? So let's start creating an M file, okay? I will not use this one at this point. So when you want to create a new file, guys, you see the cross here, the yellow cross that says new? You see that? If you just click there, script, you have your new function. Got it? So this is what is called the M file. The M file, guys, is a function that basically runs whatever you want to run. Okay. So how do we start first? Let's do a very simple example. Oh, not caps. Everything needs to start with a word that is called function. Got it? And then the name of my function. So let's call it my flips. Okay, so what I want to do here, guys, is do the flip up and down and the flip left and right done by us. Got it? So that's what I want. So this is simply the name of my function, my flips. Now, normally what you do is you first describe the program. Okay, this is one style, okay? Remember that the design is not read by MATLAB, it's simply description. So the first thing we need to describe is do a description here. What your program is doing. This is a good technique, you know. This program will create my own flip up and down, flip left to right, for example. Okay. And then you can add as many description, anything that can help the people, the description. Well, description. So anything that can help the individual is going to read your program to understand what you're doing. So this is a simple description. Now, what we want from here, so let's enter my matrix A. I will copy my matrix A that we have created here. I will just copy this one here just to have something to test. Okay, so this is going to be A. Now, how do we create a program? How do we create a flip? Let's create my flip. Or I can call this AUD. I will call it that. And I will create A left to right. Okay, so these are going to be the name of my variables. So how do I transform this one here up and down? If I receive a matrix, what I will do is simply, this is going to be equal to A. I'm moving what? Up and down, so rows, right? So this means size of A, comma 1, minus 1 to 1, and everything. Do you agree with me or not? This is what we have done. So this is the way of moving up and down. Left and right are going to be based on columns. So this is going to be every single row. And these are going to be the columns. And that's all. Do you agree with me or not? No, we'll call this my flips 24. Okay, guys, so this is the structure of a function. It always starts with a name. Sorry, with the word function. This is the name of my function. Normally you do the description. This is good for you if you return after 2 years to your program, you understand what you're doing. Then I'm including here the data. Of course, we're going to move this later. And then I do whatever I want with my data. So in this case, what I'm interested in is producing A up and down, and A left and right. This is basically the flip up and down and flip left to right in MATLAB. Got it? Just an example. So let's save this one here. So let me save this one. MATLAB files, yes, I'm okay. My flips 2024. Are you with me, guys? I need you to do this with me, okay? This is a kind of a slow class, but next class you're gonna do this by yourselves. So everyone is here with me.
Yes.
Yeah.
Okay, so once you have this program and the data is in the program, this is very strange, right? But if the data is in the program, what you do is you simply run. And you can see the results here, guys. Look, I have clicked just run, and this is what appeared. AUD, exactly what we want. ARR, exactly what we want. Do you see that? Have you been able to run your program, guys? It runs or not?
Yes.
Everyone?
Yes.
Yeah.
Okay, good. You know what is the problem with this part here is that the data is in the program, right? And yeah, of course, this matrix A is a very small one. Yeah, but imagine that we have a huge matrix of data. You're not gonna copy the data in the program. So normally what you need to do is you need to create a program that calls the data. Got it? You input the data to the program. Got it? So what we are gonna be doing is I will copy this one here. I will just comment this out, okay? Now, do you see that the issue here is that if there is no data, the program is not going to do anything. So that's why this program needs to be modified in the following way. So you need to input data. Got it? And this input of data here, guys, needs to have the same name of the variables that you're going to be using later. And then where the data comes from, I will show you, of course, later about MATLAB, Excel, CSV, or whatever other format. So you have the data from outside the program. Now, how do you call a program that has no data inside the program? You need to necessarily call this from the command window. So in order to run your model, you need to run this from the outside the main program. So you need to type my flips, you name the program, and then you put the data, and the data is going to be basically imported into the program, and then we run. So here, you don't click on the run, you simply write this part here and run. Let me move this a little bit. So this is the way you call your programs, guys, when you have data exported from or imported to the main program from outside the main program. Make sense? Okay, now, so these are called inputs. Now, what you can do also with your program, guys, is that you can create outputs. You know, if I put semicolon here, what is going to happen with my program? I'm just changing this to semicolons. Run this program again from here. Nothing. Do you see that? Why is nothing? Because I semicolon this one here. When I semicolon, simply that the MATLAB doesn't, MATLAB computes the program, computes the variables, but it doesn't return anything. So that's why in the programs, normally what we have is an output result. So let's call this, what I want to output from here is AUD and ALR. This is what I want to do. So this is the complete program, guys. AUD, ALR, these are going to be my outputs. And these variables are these ones here. And I want to run my program, it's called myflips24, using data A. Got it? In order to run this program, you need to basically copy this one here. And then you have your results. Then you can do whatever you want with these results. Make sense? Guys, can you test this with a null matrix? Create a 4 times 3 matrix. Okay, guys. Have you tested with a different metric? So let's create, for example, another A, okay? I will call this, remember that the name here doesn't, it can be whatever. I can call this B, and I will create a matrix that looks like this. 10, 11, 12. Oh, so I want to see this. So let's do this. So this is my matrix now. Do you agree? So I want to apply my program. In my program, I will call it, yeah. Here is the name of the file that I'm going to use in the program. So I need to use B. But for MATLAB, guys, this B is going to be transformed into A in the program. Makes sense to you guys? This is crucial. So the names that you put here are not necessarily the same as the names you put here. However, if you have more variables here, okay, so if you have A, B, C, D, E, the order must be the same. So imagine this is years, the other one is months, the other one is etc. So it needs to follow the same structure as this one here. It makes sense to you? The names can be different, but the structure is going to be the structure needs to be correct. Make sense? Guys, make sense?
Yes.
Perfect. Okay, so your program ran or not? I'm sorry, what happened? Was able to run? Here you go. You see? Now, if I don't want to, I don't want this to appear here. So how do I do that? What I can do, as usual, guys, I will do semicolon here, but take a look to whose. No, well, whose. Your variables are already here. So even though you don't show them, they are here. Make sense? Make sense to you guys?
Yes.
Okay. So the next thing we can do, guys, the next thing we want to do is imagine that we want to sum two matrices. Okay, so remember the condition for sum of matrices is simply that the number of rows and columns equals the number of rows and columns of each of the variables. Got it? Of the matrices. So for example, if I have A and A equals 1, 2, 3, 4, okay. B, imagine that B is equal to, I don't know, 4, 5, 6, 7. So you can sum these two matrices, do you agree? You can sum A and B. Got it? You can do that. This is correct to do. The problem is that if you have one of the matrices has a different dimension, so in that case, you cannot do that. So now create yourselves, guys. So open a new script. Let's create a function, mySum. And what I want you is that you're going to be accepting two matrices, A and B. And I want you to sum the matrices. That's all. So I want you to return the sum of the matrix. That's all what I want. And perhaps let's call the output, let's call the output to be C. Okay, 2 minutes to do that. Well, 3 minutes to do that. One minute, guys. Well, guys, it's very simple, right? If I want to sum two matrices and I want to call my output C, well, simply the variable I need to create here is going to be called C, and C is going to be equal to A plus B. Agree with me or not, guys? Straightforward. Straightforward if we don't have issues. Guys, make sense to you? So if we want to run this program, remember, we need to run this from the main command window. So I have created already A and B, and now what I will do is simply run this one here. So the sum is going to be 5, 7, 9, 11. So let's take a look. 1 plus 4 is 5, 2 plus 5 is 7, etc. Make sense?
Yes.
Okay, so now what happens if I change B? Okay, B is going to be 8 and 9. So B is like that. Remember, A is like that. So obviously now we have an issue, correct? Because the number of rows of this one here is different to the number of rows of this one here. So A plus B, if you try to do A plus B, you see, incompatible sizes of this operation. So it doesn't work. So try to run your program. let's try to run your program. You see, it's gonna tell you, hey, there is something wrong here. Make sense? So that's why, guys, what we need to do is we need to start looking for conditions in my program. And then what we're gonna be using here, guys, is something that is called an if statement, okay? So an if statement has the following shape. Let's do the simple one. Is if, and then you end up with end. And you write something in between. So you have if, condition, and then you write something in between. Got it? But before doing that, so what is the main condition here, guys? So when I have A and B, the number of rows of A must be equal to the number of rows of B, correct? And the number of columns of A must be equal to the number of columns of B, right? So let's first determine the number of columns of A and B. So let's call this, for example, n comma m, and this is going to be equal to size of A. Okay, and let's do the same. But now let's call this IJ, something like that. And now this is going to be of B. Correct? Now my condition should be that M must be equal to I and N must be equal to J, correct? But I want to find an error. So what I will say is the following. If M is not equal to I or N is not equal to J, right? So I'm violating already the conditions. What I will do is I will send a message. Error. Your matrices are non. You can write whatever message you want, guys. And then I don't need this space. I'm sorry. Okay, so this is the way the if conditions work. You have if, what are the conditions? You can use here the logicals. In this case, remember this bar here means or. This tilde means not equal to, and this not equal to. And the error is simply going to provide you a message. So this message is going to appear, instead of this message that you have here, it's going to appear this message. And then the program simply ends. You see, guys, when you try to run your matrix, A plus B, your matrices are not conformal. This is your message. Okay, so we can do let's transform A. So let's put this, for example, 9 and 11. And now I can sum, right? Now I can sum. Questions, guys? Is it clear?
I just have a question. When
Yes.
I change B and add 8 and 9, like the new B,
Yeah.
it doesn't for some reason it's not like recognizing that and it's just using the old one.
Wait. So you have done. Can you show me your screen? Give me 1 second. I need to allow you share your screen. Yeah. Can you share me your screen? We can do this very quickly.
Mhm. So I change it and run it again, but
Yeah. Can you put B and just type B? I want to see. Yeah. Yeah, this is B. This is correct.
if I do this,
Yeah. Wait a second. So can you check A? That's strange. Yeah. A is okay. And B, type B again. Ha! What? That's really weird. Can you go again, A and B? Wait a second.
Yeah.
So why? Yeah, can you call A? Yeah, try to do A plus B directly there. A plus B. Yeah, okay, do your program. Yeah, and don't run. Yeah, wait. No, don't run for a minute. Oh, yes, because you have A and B in your program. You need to comment out your program. You see in the function? You have defined A and B here in the main program. No. You see function?
Yeah.
Yeah, you have defined A and B there. So
Oh,
basically,
sorry.
whatever you receive here is going to be, yes, if you, no, you don't need to do that. Huh? You just comment this out. Comment out the percentage sign at the beginning of 3, the beginning of 3.
Uh-huh.
Yeah, yes, no, to the left, one to the left. Yeah, comment the percentage sign.
Okay.
And also in B.
Okay.
So you don't want to have the data. When we created this at the beginning, we just wanted to show you, but indeed the data should come from outside. You see?
Okay.
So now when you comment these two things, is that the MATLAB program is going to take what is provided by you as A and B from the command window. So can you run now?
Okay.
Yeah, careful that you have one parenthesis missing. Yes, arrow up. No. Yeah, okay, now yes. You
Okay.
see? Now it works.
Thank you.
Okay, pleasure. Okay, guys, so let's continue. Where's my screen? Okay, so now what we are going to be doing, guys, is, okay, I have a program here that does A plus B, right? I want you to modify this one here, okay, in such a way, and take a couple of minutes. Now you're going to have A, B, and C. Got it? So what I want from you is to basically sum A and B and C and create a matrix that is called D. Do you understand? So now you're going to have 3 matrices. And then you want to sum A, B, and C, and the result is going to be D. How do you do that? Just think a little. Let's think. Copy this one here and copy the other one. You know, I don't know. Create a new matrix, a new file. Let me open a new one, and then you can copy this one here. So don't delete this one here, okay? Don't delete this one here. Create a new one. So let's call my sum 24 3M, for example, something like that. Let's save this one. Yeah. So modify this one here. So what I want, now I will enter A, B, and C. And my result is going to be stored in D. Got it? And D is going to be simply the sum of A plus B plus C. Now, however, there is a small trick here, guys. How do I process this? Because I want you to learn how to create programs in programs. I want you to call Okay, so let me think. Because if you do AB plus C, you simply do plus C here, right? And that's it. And then you need to create more conditions here. Yeah, let's try to do that. Okay, just create your program that does AB plus C. And of course, verify that the dimensions are correct. Ready, guys? Someone? Hey guys, you tell me. You tell me, guys. So the program is easy to modify, right? So what I can do is I can create a new one just for my conditions. I don't know. KL could be size of C. And then here my conditions are going to be basically, or I can use any, right? M is not equal to K. Correct, guys? So I want to be sure that the conditions or any of these conditions are violated, then we are done. Any not equal to L. So let's create another matrix C that is going to be 9, 10, 11, 12, 13, 14. It's not C, this is going to be D, A plus B plus D plus C. Agree with me?
Yes.
Okay, so should work. So let's try to save this one here. Let's run the program. But I want to show you something different, okay? I want to show this in a minute. Yeah, here we go. Right, now what happens if, imagine I will change C. C is only like this. And I try to do this, your matrices are not conformal. Got it? So let me put this again here. Now, guys, what I want to show you with this very simple example is the following, okay? Normally, MATLAB has this beauty, well, it's R or Python also have the same characteristics that you can use a single program to start adding multiple programs. Okay, so what I mean is the following. So imagine that I will do, okay, we'll call this 3, I will call this big one. Okay, so let me save this as a big one. So your previous version is okay, guys. So what I'm doing is I'm modifying this stuff to do something different. Okay, so what I will do is the following, guys. I will call D A plus B. Okay, but I don't want to do the sum in this program. What I want to do is I want to call my previous program. Do you remember this flips up and down? Do you remember this? No, not flips up and down. I don't need this one. My sum, this one here, do you remember? Guys, please pay attention here because this is important, okay? It's very simple example, but this is important. So do you remember this program here? What you do is you input, you need to have this information, and then this program is going to do the sum of two matrices already, correct? So what I will do here is instead of using A plus B, what I will do, it's not this one. What I will do is I will call this one here. So D, let's call this D1, is gonna call my previous program and will include, no, why is doing this stuff? Okay, so fine. So what I'm doing, guys, is I'm calling my program, the one that I created. So what this one is going to do is what? D1 is going to be equal to the sum of A plus B, correct, guys? Guys, you agree?
Yes.
Okay, and then what I get from here is my, what's going on? And then what I do, this is D1. What I can do is create D2. That is going to call again my program. Oh, sorry, this is going to be the final D. And what I will do is I will sum D1 with C. Do you see that? So what I'm doing is I'm using a program that repeats many times because the sum of 3 elements is the same as the sum of 2, then the sum of these 2 with the sum of the next one. Do you agree? So what I do here first is D1, I sum, I use my program that I computed before. I created D1, D1 is A plus B. And then what I do is D1 is A plus B, and then I simply add C, and then I'm done. I compute my D, okay? So this is a very naive example here, but you're gonna see the use of these type of techniques in a couple of minutes. Can you try this one? So we run the program as usual. So this is going to be D, and that's it. It's exactly the same result. But now what it's doing is using your own program. So it's using this program here. Okay, try to do this, be sure that it runs, and then I will show you one trick to evaluate your programs. Okay, guys, are you with me? 2 more minutes. This is a kind of a slow class, but next class you're gonna be able to create a lot of things, guys. You're gonna see. Okay, guys, makes sense to you? So basically what I'm doing is I'm calling a program within another program, correct? Now, there is a trick here that I want to show you guys. When you want to debug the program, what you can do is the following. Just put your cursor in a number. You see a row number 17? Click there and appears a kind of a red box. Do you see this? Guys, do you see this?
Yes.
Okay, so let's try to run now our program. You know what it does? it stops where you have told them to stop. And take a look. Now, if you put your cursor here, M is 3, N is 2, appears A, etc. Make sense? Now, this one here is calling, and you see this flip, this arrow here that is going down. It says, okay, D1 is calling this one here. Okay, now what I can do is I can go to my program here, to this one here, and then perhaps I can stop it here. I want to see what's going on up to here. Go back to your program, continue. And then now this has a stop here. And you can see it has the values of A, has the values of B, and it's gonna make that a sum. And it's gonna return to you, something that we call D1. Okay, I will put another arrow here, continue. And then here, take a look. We have computed D1 is already A plus B, do you see? And then we're done. And then you simply continue, and then your program is finished. Oh, I need to run once more. Once more. Yeah. Where is that here? Oh, I need to go to this one here. Give me 1 second so we can run this again. We don't need this stuff. We run from here. And here you go. Make sense? So if you want to stop your program somewhere because you know that there is a mistake there or some issue there, you just click on the row number of your program, and then the program is going to stop there. Make sense? Questions, guys? Okay, guys. So now, questions before I continue. Questions here. No questions? I have sent you guys in your emails one program that is called Census Data Analysis. Have you received that? And it has age selector, it has gender selector, and it has edu selector. Can you open all of them? So we'll close my sum. We'll close this one here. Can you open census data analysis? Have you received this email, first of all?
Yes.
Yes.
Okay, so can you open the 4 files? I will explain it to you briefly, and then I want you to understand the program. And I want you to start debugging one by one to understand what is going on here. Okay, open this 4.
Can we close out the other
Yeah. Close that.
programs? Okay.
Yeah, we don't need them. We just need this ones here. Okay. Have you opened the files? Okay, guys, have you opened the file? I need your input, otherwise I don't see you. So,
Yes.
okay. So perfect. This is a very simple example, guys. You have X, you have H. So the first column, sorry, row is going to be age. And the second row is going to be simply gender. Okay, 0 is male and 1 is female. Got it? That's all. So take a look to what the program does. You know, let's say this program uses, we use this program to show how you can call several programs using a master program. So a master program, guys, is a program that basically calls other small programs. Right? Take a look. Take a look to what happens here. Of course, I can compute directly I can select the males using the data here, correct? But instead of doing that, what I'm doing is I'm calling a variable, a function that is called is called gender selection. And what I input here is the data and 0 because I want select from X all the males. And the same program can do the same, can do select from X all females. You see, that's why I don't need to be repeating all the programs. I simply call a program that does something specific. Let's go to this is gender selector. Look, gender selector receives the data, receives the gender, so it's 0 or 1, and then simply collects cleans the data. It's find the data that 3, because the third column, the third column contains the gender, etc. Am I right? Let me check this one here. Oh yeah, we are transposing, so this is good, etc. Okay, guys, you have let's say 5 to 10 minutes to understand the program. Now, what I want from you is to test. Okay, so you want to see what is this part doing. So what you do is you go to gender selector, just click here, and then you run. Run this one here, and then you see, okay, so what is the data? Oh, the data is this one here. What is the gender I'm interested in? Oh, 0. Oh, got it. So, and then you understand what you're doing here. Got it? And then you continue. Okay, 5 to 10 minutes, guys, to do this stuff. Understand what we are doing in this program. So you have already a built-in program. Okay, guys. Questions about the program? Someone? Guys, questions? Doubts? Do you understand the program? Have you run the program? Okay, we'll do this step by step, okay? I need your input, guys. I don't hear you. I don't know what's going on. So I run my program. As soon as the data is in here, I run from here. So I have the males are these ones here. So what is the first one? This is the ID, individuals 2, 3, 5, and 7 that have 17, 22, 17, and 16 years old are all male. Now, in terms of the females, I have, these are the females. Individual 1, 4, 6, 8, and 9, etc. Okay, now, okay to drink selector. What I'm doing is I'm using a new program that is called the age selector. What I do is, okay to drink. So one is what? Let's see. Okay to drink equals 1. Okay, so I want to, this one here implies that I want to select those individuals that are older than 21 years old. Got it? I have defined this by myself. So I define 1 to be okay to drink and 0 not okay to drink. This is up to you. You can define the opposite. You can put whatever number you want. The thing is that here you're using a new program that is called the age selector. What is my age selector? I want to go here. Okay, we'll put a stop here and we'll run my program. Okay, so my data comes. My int is 1 is okay to drink. And then what I do here is a new command, guys, that is called the if-else condition. Take a look how this works. It is if you're going to have a condition. Else means that if this condition is not satisfied, then you do the other part here. Okay, so in this case, if int equals 0, so I'm looking the not okay to drink. Basically, how do I identify the not okay to drink? From the data, I find column number 2 is the age younger than 21 years old. So find all the rows that satisfy this condition and provide me all columns. This is with int equals 0, this one here. If it's in equal 1, so it's the else. So what I'm doing is I'm finding from that all columns, and the condition is going to be that the second column are larger or equal to 21 years old. Okay, so I will go back to my census and I will see what happens here. So I continue. And then I have my okay to drink people. It's going to be individual 3, has 22 years old, it's a female. Individual 4, individual 6, 9, and 10 that have these ages here, and they are sorry, this is male and these are all females. Make sense, guys? So I can close this one here. Now I have select all males that are okay to drink. So what I've done now is that my input is not going to be the complete matrix. My input is going to be only the matrix that contains males, that we have done this already. And then from these ones here, I will select those that satisfy the condition of being older than 21 years old. Obviously, here we have only one, right? So we can take a look to that. Yeah, I don't need this. I can continue running. So there is one individual number 3 that is 22 years old, and this is a male. And then you do, you continue doing. I want to see all the females that are not okay to drink. So what I do is gender selector, not okay to drink. I have compute not okay to drink here. No, and 1. And then I continue doing that. Now, what I'm doing here, guys, in the next step is I have added my variable y. Y is years of education. So what I'm doing x2 is simply that I'm joining x with years of education. So basically, if I run here, I have my x2 has ID, age, gender, and years of education. Correct? And then I do selector x2 0. What is 0? 0 means high school. Yeah, high school is 0. 1 is college or grad student. So I want to select all the high schoolers here. So let's go to edu selector. Let's put this block here. And then I can run. So my data, complete data. My index is 0. So this is high schooler. This is what I'm saying. If index equals 0, only high school. I select from, I call this variable edu data. Select the data from DAT. And the condition is that the fourth column of DAT that contains, the fourth column is the year that contains years of education, should be smaller or equal than 12. And that's it. So if we continue this stuff, let me stop here. We can find that the people that have only high school are those individuals, 1, 3, 4, 5, 7, 8, and 9. The genders are here, the ages are here, and the numbers of years of education here. Make sense to you guys? Okay, we can do grad school. No, gender selector, grad education, these guys here. So what I'm doing here, upset. Yeah, I don't need to. So what I'm doing here, guys, I have selected all those that have graduate school. We have 3 individuals, 1 male and 2 female, ages and years of education. Okay, now what I want to do is I want to select from this one here, all the males. So I use gender selector. You see that, guys? I use gender selector. I only send the grad education guys, and then I'm selecting the male. So if I do this, I have this here. So only individual number 2 that has 17 years old is a male and has 13 years of education. We're almost there. And then we can do all females, high school, and okay to drink. We can do a lot of things here, but I want you, do you have questions here? And there is an additional trick that I always use here in the programs. I normally, guys, at the end, I write D. D can be whatever letter you want, A, B, C, whatever you can imagine here. But this has nothing to do with the program. What is interesting about this D, guys, is that if I put the red button here, what it will do, the program will stop here. And then I have all the data here. So I can analyze all the program, because I have stopped the program here. Of course, I cannot, once I'm done, I comment this out or I delete this D so the program can run independently. But I can see, for example, all the females graduate with graduated education, individuals 6 and 10, these are the years, are females, and these are the years of education. You see, average age of the high schoolers, 19.29, because I'm using all these guys. These are all the homeschoolers, sorry, the high schoolers, and then the average age is going to be 19.29, etc. Questions, guys?
Hey, Professor.
Yes.
In all the functions you use DAT. Where's that come from?
Oh, this one here. No, it's a name. I simply put this. This is, remember, these are names. You can name it as you want. Okay, the only thing that you need to remember, so for example, age selector. So let's go and check one that uses age selector. Yeah, gender selector is also good. You see, gender selector, I put that DAT gender. So this one here is the variable that I use here, correct? But this one here is called in the program as X. So that's what I was telling to you. The only thing that you need to be careful is that the name does not need to be the same as the previous programs. So what I'm doing is this X is called in gender selection DAT. You see? And this 0 represents the gender here, this one here. Make sense to you? These are simple names,
Thank you.
just names. Pleasure. Okay, guys, more questions. Okay, so you need to review these programs here, guys, because we're gonna start complicating our lives, starting next class. So now what I want from you, and then we can stop here, is the following, because we have done quite good. So I will send you another file that is an Excel file, and I will explain to you what this Excel file is. Give me 1 second. I will send you one more file. Where do I have this file? 1 second. Okay, I have sent you one Excel file, guys. Can you open that Excel file, please? I will explain you what this model is, and then you tell me when you have received your file, guys. Okay, do you see my screen, guys?
Yes.
Yes.
Okay, so now this is what we're going to be creating in MATLAB, guys. Okay, so I want you to create a program. Okay, the inputs are going to be, let's call this principal. Let's call, you know, int, or let's call this annual int. That is going to be this 10%. And then end period, months. Oh, no, it's months. Okay, so I want you to create, guys. So let's do first this program. I want you to arrive to this part here. So the inputs are going to be, your program is going to be, your function is going to be called my annuities. Okay, so this is going to be the name of your file. Create a new function. The inputs are going to be principal, annual interest rate, and end period per month. And I want the result just to be the payment. Later we're going to prove. So I want just you to arrive to this number. Now, guys, the factor is this one here. So this is the formula that you need to use. You need to implement in MATLAB this formula. You have this in Excel. Just understand how the formula works. Implement this formula to compute your factor. And once you compute your factor, so wait a second. So this is annual. You need to transform this into monthly. So you have the formula here. Once you have this monthly, you need to compute your factor. And once you compute your factor, you simply multiply the principal times the factor, and then you obtain the PMT. Make sense? It's 5 minutes to do this stuff. Your program is going to be called my annuity. Inputs are going to be principal, annual, and periods, and PMT. So your principal is $10,000. Your interest is 10%. Number of months is 9. Okay, just compute up to this point. Okay, guys, do you understand what I'm requesting from you? Guys, if you don't write, I have no idea if you understand what I'm asking to you. Guys, do you hear me? Abdi, Cameron, Nicole, Ying, Boitumelo.
Yes.
Okay, perfect.
Yeah.
So you understand what I'm
Yes.
trying to do. Just today, I want just you to arrive to this point here. That's all what I want. Give me the payment. You have the formulas, you have everything. So I just want you to arrive to this point here. Five minutes to do this, and then we start talking, okay?